Okay, we are going to today look at adding and subtracting. We're going to add and subtract rational expressions. So we're going to be looking at sections 3 and 4. Section 3 is more of a skills practice section, and then section 4 is doing the addition and subtraction problems. Okay, so that's what we're going to be looking at. Before we get started, I want to review basic fractions. If you have, let's say, 3/12 plus 2/12. If you have two fractions that have the same denominator, the denominator is still going to be 12, but we can simply add the numerators. The 3 plus 2 is going to give me a 5. 5/12 cannot be reduced any further, so that would be my final solution. If I had, let's say, 2/20 plus 8/20, I have the same denominator, so that means I can add my numerators. 2 plus 8 gives me 10, and the fraction 10 over 20 can reduce, and that would become 1/2. So back in module DMA 20, that was the module on fractions and decimals. So when you have the same denominator, you just simply add the numerators, and then you would reduce that answer if it can be reduced. Now, what's going to happen if you have, let's say, the fraction 2/3 plus 4/5? If I want to add these two fractions, my denominators are different. So the first thing I'm going to have to do is I need to find the least common denominator, or the least common multiple of the two numbers in the bottom. Once I find the least common denominator, the next thing that I will need to do is I will need to make equivalent expressions of those with the new denominator, and then I'm going to add the new numerators together. So before we get into what we're doing today, I wanted to share with you this in the form of basic fractions. So with the denominators of 3 and 5, if we multiply 3 times 5, that gives us 15. That would be our least common multiple, or we might call it our least common denominator. In order to do this problem, I'm going to take the fraction 2/3, and I need to multiply it by something to get the denominator of 15. I also need to take 4/5, multiply it by something to get the denominator of 15. This is the part where I'm going to make the equivalent expressions. We can take any fraction and multiply it by 1 and have an equivalent expression. So what we need to do is to say 3 times what number is 15? That would be a 5. The fraction 5/5 is 1 whole. So 2 times 5 is going to give me a numerator of 10. So 2/3 is equal or equivalent to 10/15. 5 times what gives me 15? A 3. So 3/3 is my 1 whole. 4 times 3 gives me 12. So 12 over 15, that would be my new equivalent expression. So what I'm going to do now is I'm going to be adding this numerator of 10 and the other new numerator of 12. 10 plus 12 is going to give me 22/15. I would look at this fraction. If I could reduce the fraction anymore, I would. But in this case, they don't have any common factors. So this would end up being my final answer. I'm just going to write simplify if possible. In this case, this one could not. So I'm just trying to make what we're going to do today seem very simplistic. So what we're going to do is we're going to take these denominators, the 3 and the 5, and figure out how to come up with the 15. Ours aren't going to be just whole numbers. Ours are going to end up being a variety of expressions. We are then going to do a skill practice like I've done here, which is making equivalent expressions. Once we've done that, section 4 is where we pull it together and we add the new numerators to get an expression, and then if we can reduce, we do so. Okay? So I hope by seeing this, it relieves a little bit of your anxiety that it's not going to be a hard process. It's just, I like to use the word tedious, and you just have to pay attention to detail. So where I'm going to begin is I'm going to start with, and if you want to look in your workbook, I'm going to do some of the workbook problems on 7-19. We have, at the beginning, you're going to have expressions that have the same denominator. So if we have the same denominator, we're going to combine the numerators. Both of these have the common denominator of 5D. The top I have 8C plus 2C. So I'm going to combine these. 8 and 2 give me 10C. The only thing I can do here is reduce the 10 and the 5. 5 goes into 5 once, it goes into 10 twice. So my final solution is 2C over D. So if you can simplify the whole numbers or the variables, you would do so. Let's look at another. Here we have 12x over 3x minus 5 minus 20 over 3x 5. The two denominators, we look at them and identify that they are the same. They are a common denominator. So in this case, I can just combine 12x minus 20. Now, technically, we can't combine those as like terms because they're not like terms. But we do have 12x minus 20. In order to simplify, I would see if I could factor a common factor. And these two both have a common factor of 4. When I factor 4 from 12x, I'm left with 3x. When I factor 4 from 20, I'm left with a minus 5. My denominator is the 3x minus 5. So, can I simplify anything here? Yes. That 3x minus 5 is going to cancel out, and my final solution here is just the whole number 4. So at the beginning of section 3, you are going to work problems where you will be having the same denominator and you'll be combining the numerators. Okay, let's do 2 more of these. Turn over to page 720 and let's look at these 2 problems. Okay, we have 2x squared plus 7x over x minus 7 minus, and then we have 10x plus 77 over x minus 7. Now, both denominators are the same, so I can just bring that down. Now, the key thing here to point out is, do you see we have a minus in the middle? A moment ago, when we had subtraction here, there was only one term, a 20. In this one, there's 2 numbers that come after. So let's take note of what we have. The 2x squared plus 7x, I'm just going to bring that down here. Now, before I write anything else, let me change the color to draw your attention to what we're doing. Since there's a minus, we're going to, in essence, distribute a -1 to both of these terms. So -1 times 10x would make that minus 10x. Most everybody determines the first one is changed to the minus. However, this is where people generally just leave plus 77 and their answer is wrong. What we have is -1 times positive 77, which would be a -77. So the signs for both of these terms are going to both change and become minuses. Now we want to combine like terms. So 2x squared is by itself. I'm going to combine 7 minus 10 is negative 3x minus 77 over x minus 7. In order to simplify my answer, I need to see if I can factor that numerator. So this is where we use those dma070 skills. We're going to factor, we're going to do 2 times negative 77. And so what I want to do is, I'm going to put my answer here in just a moment, but I'm going to do my work at the bottom. So here, I need to remember to divide both answers I get by 2. 2 times negative 77, 2 times negative 77, negative 154. So we have negative 154 divided by x, and then we're going to have y1 plus x, second table, and we're going to look for our middle number, which was a negative 3 in the third column. So I've got to scroll down a little bit. I'm looking for a negative 3. There we go. And that gives me a positive 11 and a minus 14. So we have a positive 11 and a minus 14. For the first term, I cannot reduce 11 halves, but I need to do bottoms up, and that's going to become 2x plus 11. For the second term here, I can reduce 14 divided by 2, and that's going to give me minus 7. So my next step, now that I have factored my numerator, is can anything cancel out? So this is kind of reviewing what we did in sections 1 and 2, where we had to factor and simplify, or factor, multiply, or divide, and then simplify. So here, this x minus 7 is going to cancel. My final solution is 2x plus 11. Okay, and we're going to do one more before we move into our skill practice. So let's look at 3y over y squared minus 3y minus 10 plus 6 over y squared minus 3y minus 10. Now, both of these denominators are the same. However, as you notice, the denominators are not factored. So we have 1 times negative 10. We don't have to write what to divide by here, so let's go to y equals, and we're going to do clear negative 10 divided by x, second table, and our middle, whoop, give me just a minute, let it load. My screen's locked up. Okay, second table. We are looking for a negative 3, and here we go. We have it up here at the top. So with a negative 3, we have a negative 5 and a positive 2. So we have a negative 5 and we have a positive 2. So you factor the denominator, and then on top we have 3y plus 6. Now, can we factor the 3y plus 6? Yes. They both have in common a 3. And when I factor a 3 out, I'm left with y plus 2. My denominator is y minus 5 and y plus 2. So this numerator we factored here. Now that we have factored that numerator, is there anything that can cancel out? The y plus 2. So we're left with a 3 over the y minus 5. And if it helps you, just keep a parenthesis around your binomials just so you accidentally don't go in and do something, trying to cancel something more than it can be. Okay, so that's going to be your first part of section 3. Now, the next thing we're going to look at is finding a common denominator. We're going to look at finding a common denominator. Now, we're not going to have just whole numbers. We're going to also have a variety of variables. If you look in your workbook on page 7-23, I'm going to use the denominators that they have given us here also. In the first problem, the denominators are 7x cubed and a 5x squared. So we're only going to look at those two denominators. You have nothing to do with the numerators. This part is going to be a skill practice only. So in the first one, I have a 7 and I have 3 x's. In this next one, I have a 5 and I have 2 x's. So once I factor the denominators I've been given, I've got to have a 7, I've got to have a 5, because I've got to have every factor in it. I have how many x's? 1, 2, I need to have a total of 3 x's. So to find my least common denominator, 7 times 5 is going to give me 35, and I have a total of 3 x's. So if I only had 2 x's, it wouldn't be enough for the 7x cubed to go into it. So for every individual factor you have, you're going to need to use all of the factors to make that least common denominator. Okay, let's look at the next one that you have there. We have one denominator is a b plus 4. So when I look at that, I can recognize that's already factored. The other one is b squared minus 16. Now, this I do need to factor. That's a difference of squares. It's a b plus 4 and a b minus 4. We need to factor. This one is already factored. It's just b plus 4. So when I'm determining my least common denominator, this one has a b plus 4. So does this one. I only need one b plus 4. The most either of them have is a single b plus 4. The other one has the b minus 4. So that would be your least common denominator. Okay. For the next one, we have a 3x plus 6, and we have 3x squared plus 12x plus 12. So both of these need to be factored. For this first one, I can factor out a 3, and then I'm left with x plus 2. Now this one, it's in the right order, and before I start doing 3 times 12, all of them have a common factor of 3. When I factor out the common factor of 3, I'm left with x squared plus 4x plus 4. So when I finish factoring this, this is going to become, we're going to have the 3, and this part is going to factor to become an x plus 2 and another x plus 2. So to find our least common multiple here, they both have a 3. This one has one x plus 2, but here we still have another, so we're gonna have to have both of those x plus 2. Okay, let's do one more. Here we have a denominator of, we're only looking at the denominators, x squared minus 10x plus 21, and we have x squared minus 4x plus 3. Okay, so we're going to factor both of these into common factors. So for the first one, just use your calculator. We're going to do clear 21 divided by x. Second table, our middle number was a negative 10. Okay, so I need to go in the other direction and find the negative 10. Okay, and that gives me a negative 7 and a negative 3. So an x minus 3 and an x minus 7. For the other one, we have a 1 times 3. So that's going to give us 3 divided by x. Second table, and we're looking for our middle number, which was a negative 4. Negative 3 and a negative 1. So negative 3 and a negative 1. Now, as we determine our least common denominator, we have to use all the factors. Both of them have a single x minus 3, so we have to use x minus 3. This one has only an x minus 1, so we need to have that one. This one also has another one, which is the x minus 7. So all three of those are going to make the common denominator. So that is that particular part. That's a skill practice section. The other skill practice section, if you flip in your workbook to page 7-25, this is where we are going to make equivalence expressions. This was the part where I multiplied by 1 earlier. So what they're going to do is they're going to give us an expression. So we have 5 over 2x cubed y to the 4th. What they do is they just write equals, and then they give you this, 8x to the 6th y to the 4th. When you do your problem, when you write it on paper, what I want you to do is I want you to give yourself a multiplication sign and a little blank, because you need space here. You don't have to draw the big one that I'm going to do. I just do that for emphasis. You don't have to draw the one. But what I want you to do is know you need to put a place in between this and the equals so that you have some working space. So you're going to ask yourself, 2 times what number gives me 8? That would be a 4. If I have x cubed here and x to the 6th here, how many more x's do I need? I need 3 more to get to x to the 6th. If I already have y to the 4th and the exact same one here, I don't need any more y's. Whatever's on your denominator is going to become your numerator because that makes it one whole. To get the new numerator, you are just simply going to distribute. You're just going to distribute. So 5 times 4x cubed is going to give me 20x cubed. For these problems, do not try to simplify them. All you're doing is finding the new numerator so that you could then combine both new numerators, and then your next step in section 4 after that, after combining or by adding or subtracting, is when you would simplify. So for right now, we're just doing a skill practice of just determining what is the new numerator. Okay, so let's do another one here. Let me change colors. Okay, so we have y over 2y minus 6. I'm going to leave myself some working space, and then they give us 12 y minus 6 y plus 3. Okay, so in order to go from the 2 to the 12, I would need to multiply by 6. 2 times 6 gives me 12. Here I have a y minus 6. Here I also have a y minus 6. I don't have the y plus 3. So I need to include the y plus 3 here. Now, as I put this on top, I'm going to show you a trick that I like to do. If you have a number in front of a parenthesis, normally we would want to distribute that. So when I write it up here, I'm going to write 6y, and then 6 times 3 gives me 18. I'm going to go ahead and distribute when I write it on the numerator. Now, all I have to do is to distribute this y times those two terms. So y times 6y is 6y squared, and y times positive 18 is plus 18y. You're finished. Stop. Don't simplify anything. Okay? Here we have another. We have 2 over 3, 2x plus 1. I'm going to leave myself some working space, and then they give me 6x, 2x plus 1, and an x minus 3. So I need to determine what do I need to multiply by. To go from the 3 to the 6x, I would multiply by 2x. 3 times 2x is 6x. I have a 2x plus 1 here and here. I need to use this x minus 3. Just as I did on the previous problem, when I write it on the numerator, I'm going to distribute. So 2x times x is 2x squared. 2x times -3 is minus 6x. So this we distribute when we write it on top. Now, to get my new numerator, 2 times 2x squared is 4x squared. 2 times -6x is -12x. And then stop, you're done. Let's see. Let's jump down to number 14. For this one, we have a 5 over x squared plus 6x. And then they give us an x plus 6, and an x minus 6. Now, I want you to take note here. Guess what they did not do? They did not factor that for you. So you must factor it yourself. These have a common factor of x, and then that leaves me with x plus 6. So if the denominator that you're given is not factored, you will need to factor it. So as I'm determining what is going to become my new numerator, I have an x here and here. I have an x plus 6 here and here. The only thing I'm missing is the x minus 6. And then last, I distribute. So 5 times x is 5x. 5 times -6 is -30. So that is everything that you're doing in section 3. You are adding and subtracting with the same denominator. So you just combine numerators and simplify. You're doing your skill practice to find the common denominator, and then you're doing this same skill practice to find an equivalent expression. All of this comes into play when we are then working our problems. So let me give you an example of a problem that we're going to do. We'll write one of these out with all the parts. So what I have here is I'm going to write down we have 5a over 3a minus 12 minus a minus 7 over a plus 4. Now I'm going to go ahead and give us one that's a little more complicated that has a minus and has a parenthesis after. Okay, so we'll address that. If I were to want to combine these, now this is section 4. This is where we are going to add and subtract that have different denominators. So since my denominators are different, the first thing I need to do, now this one can be factored. I need to write the factored answer. If I factor out a 3, I'm left with a minus 4. So I'm going to take that and factor it. I have to find my least common denominator. So this has a 3, this one does not, so I need to have a 3 in my denominator. This one has an a minus 4 because we have to include every factor. That doesn't. This one has an a plus 4, that one doesn't. So we're going to end up with all 3 of these as the factors for our least common denominator. Okay? That's the first thing. Find the least common denominator. Now we're going to make equivalent expressions. Find least common denominator, and then we're going to make equivalent expressions. So write them out just like we did with the previous skill practices. So I'm going to take the 5a, I'm going to write it down, and I'm going to put this least common denominator here. And then I'm going to put down this a minus 7, and I have the a plus 4 here, and then put down the least common denominator. All right, so now we're going to do off to the side this skill practice part. I have a 3, I have the 3. I have the a minus 4 and the a minus 4. All I'm missing is the a plus 4. That's going to be the same top and bottom. So distribute here, I have 5a squared plus 20a. So this is my new numerator, and the 5a squared plus 20a is going to go up here. Now, for this one, I have the a plus 4. What I do not have is the 3, and I do not have the a minus 4. Let's multiply those, and this becomes 3a minus 12. Now, what I want you to notice on this particular one, we have a binomial times a binomial. So we are going to FOIL, okay? My first is going to be 3a squared. Then I have minus 12a. Negative 7 times 3 is a negative 21a. And negative 7 times negative 12 is a positive 84. I'm not completely finished. I don't want to leave all that out. I'm going to combine some like terms. So when I combine these two like terms, I have 3a squared minus 33a plus 84. So this becomes, okay, now let me write this back. Do you see here in the middle where we have that minus? That minus is still there. All of that became 3a squared minus 33a plus 84. This is my new numerator. So what I've got to pay attention to now is as I continue, let me just draw a little line to mark that off to the side. That was my side work of making equivalent expressions. So what I have is 5a squared plus 20a. This is going to be distributed as a negative 1 to all of those terms. So that's going to become minus 3a squared. Then it's going to become plus 33a, and then a minus 84. Now, before I put the denominator, let's finish combining these like terms. 5a squared minus 3a squared is 2a squared. 20 and 33 gives me plus 53a minus 84. They don't all have common factors, but I do need to factor these. I need to remember to divide them by 2. I'm doing 2 times negative 84. 2 times negative 84 gives us a negative 168. So a negative 168 divided by x, second table, and our middle number was a positive 53. Here's my positive 53. That gives me a 56 and a minus 3. A plus 56 and a minus 3. So as we reduce, 56 divided by 2 is going to, wait a minute, excuse me, 56 divided by 2 is going to give me a 28. So we have a plus 28, and we have 2a minus 3, because we're going to do bottoms up right here. My denominator is a 3, an a minus 4, and an a plus 4. Okay, so in this particular problem, I factored it, and there is nothing that can cancel out. So since there's not, this would be left as my final solution. If something could reduce, you would reduce. So any problem that you get, you still need to continue to factor the numerator and the denominator, and then see if anything could reduce. And at that point, this would be the most complicated of what you would have in section 4, where you have the subtraction and then we had to FOIL. It's not hard, it's just a lot of tedious steps that you have to remember what you learned in DMA 60 and all those factoring rules as well. Okay?